Okay guys, so today we're going to talk about implicit differentiation. Okay, this is how we're going to find the derivative when our equation has x's and y's. So for example, if I want to find the derivative of y cubed, I'll do it the same way. 3y squared. But when you're finding the derivative and it has a y, you have to multiply that derivative by either dy over dx, multiplying it by the derivative, or y prime. These are equivalent expressions. The book puts dy over dx every time, and I just use y prime because it's easier and faster. But make sure that you can tell the difference between your regular y's and your derivative y's. So let's see if we had to find the derivative of 4x squared y to the fifth. So of course we have to use product rule. U would be 4x squared and v would be y to the fifth. Now u only has an x, so we can just go ahead and find the regular derivative, which would be 8x. When I find the derivative of v, since it's a y, 5y to the fourth times y prime, or dy over dx, whichever you prefer. Then we multiply across. 8x y to the fifth plus, 4x squared times this gives you 20 x squared y to the fourth y prime. Here, we'll try x cubed plus 5xy. So x cubed, we can just go ahead and differentiate, but here we have to use product rule in the second term. Derivative of 5x is 5, and the derivative of y would be 1 times the derivative. So 3x squared plus 5y plus 5x y prime. So one of the longer questions would say, find the slope or the derivative for x cubed plus y cubed equals 4xy, and we want the gradient of this equation at 2, 2. So on the right hand side, this is an x, so 3x squared. This is a y, it's 3y squared, but we have to add that y prime since we're finding the derivative of y. On this side, it will be product rule. And hopefully you'll see the pattern soon if you have a coefficient followed by a single x and a single y. It's 4x times y prime and 4 times y. So the next step, I need to get the y primes by themselves. So we'll move all of the y primes to the left and every other term to the right. 3y squared y prime minus 4xy prime equals 4y minus 3x squared. Since I now have all the y primes on the left, I can factor it out. Y prime times 3y squared minus 4x equals 4y minus 3x squared. Divide both sides by 3y squared minus 4x to get the y prime by itself. this is the equation of my derivative. I want the gradient at 2, 2. So notice here, I need an x value and a y value in order to find the gradient. If they only give you an x value, plug it into the original equation and solve for y. So 4 times 2 minus 3 times 2 squared divided by 3 times 2 squared minus 4 times 2. Negative 4 over positive 4. My gradient will be negative 1. Our next example gives this equation. 3x squared plus 2xy plus y squared equals 6. Find the coordinates of the stationary points. So the problem starts off the same way we did the last one. You get 6x plus 2xy prime plus 2y plus 2y y prime equals 0, since the derivative of a constant is 0. So once again, we'll get all of the y primes together and move everything to the other side. Factor it out. So y prime equals negative 6x minus 2y over 2x plus 2y. So since they're asking us to find stationary points, the stationary points occur when the derivative is equal to 0. So we set this equal to 0, and if I multiply both sides by 2x plus 2y, that's just going to cancel. So I have two variables and only one equation, but that helps me because I can solve for one of the equations, or one of the variables, excuse me. So I get y equals negative 3x. So we got to plug this in for every y we saw in the original equation. Which was 3x squared plus 2xy plus y squared equals 6. So every time I see a y, I'm going to replace it with negative 3x, so we have one variable to deal with. And of course, you could have done it the other way too, but then you'd have a fraction for a coefficient. Okay, so we'll distribute, simplify. So we have 6x squared equals 6. X squared equals 1. So x equals plus or minus 1. Now, we have an easier equation for finding y in terms of x now, which is y equals negative 3x. So don't try plugging this back into the original formula. That's a waste of time and energy. At x equals 1, y equals negative 3 by plugging 1 in here. And at negative 1, y equals positive 3. So those are your equations of your stationary, or coordinates of your stationary points. The derivatives of trig functions. Okay, so the first thing you need to know is that the angles are measured in radians when we're finding derivatives. So essentially, when you're doing calculus with trig functions, you're just going to think about radians. If my equation is sine x, the derivative is cosine x. And these are on your formula sheet, so use it as needed. If the original equation is cosine of x, then the derivative is negative, or the opposite of sine of x. And if it's tangent of x, the derivative is secant squared x. So let's look at some examples. Differentiate 2 sine of x. Okay, so the constant doesn't change when you find a derivative. So all we have to do is find the derivative of sine x and multiply it by the constant. So this is simply 2 cosine x. Now if I have x times cosine of x, I have to use the product rule. U equals x, and v is cosine of x. U prime would be 1, and v prime would be negative sine x. So multiply diagonally, we get 1 times the cosine of x plus x times the negative sine of x, which is equal to minus x sine x. Now if we had tan x over x squared, this would require using the quotient rule. U equals tan x and v equals x squared. U prime would then be secant squared x, and v prime would be 2x. So remember, for the quotient rule, it has to go in the order vu prime minus uv prime, and then we put that over v squared. So x squared secant squared x minus 2x tan x over x squared squared, or x to the 4th. Now you can simplify further since both terms have an x. X secant squared x minus 2 tan x all over x cubed. And now we'll try one more with this. 3 plus 2 sine x to the 5th power. So remember, we have to multiply the front by the exponent and the derivative of the inside. Well, we know the derivative of 2 sine x is 2 cosine x. So we'll multiply the derivative of the inside times the exponent, then multiply that by what's in our parentheses, and subtract 1 from the exponent. So our answer here, 10 cosine x times 3 plus 2 sine x to the power of 3. So all of those examples had a single x, sine x, cosine x. Let's look at what happens when we have a coefficient in front of the x. If y equals the sine of ax plus b, then the derivative equals a times the cosine of ax plus b. So we're still multiplying by the derivative of the inside and then changing it depending on which trig function we're given. So if it was cosine here, this would be negative sine, and if it was tan here, it would be secant squared. So for example, 2 sine of 3x. In this case, a equals 3, and sine will change to cosine. So we get 3 times 2 cosine 3x, or 6 cosine 3x. B, we'll see the same rules applied to the product rule. 4x tan 2x. u is 4x, and v is tangent of 2x. Therefore, u prime is 4, and v prime multiply by 2, change it to the proper trig function, which here is secant squared, and you leave the coefficient with the x. Now we cross multiply. 4 tan 2x plus 4x times 2 is 8x secant squared 2x. And that's the derivative. Here we'll see cosine of 2x minus pi over 4 divided by x squared. So of course we have to use the quotient rule. U is cosine of 2x minus pi over 4. So we multiply by a. We change it to the proper trig function. So cosine becomes negative sine, and I'll just move the negative in front of the 2. Negative 2 sine of 2x minus pi over 4. V is x squared, so v prime is 2x. Remember to do v times u prime first. So negative 2x squared sine of 2x minus pi over 4, and then we subtract v prime times u, minus 2x times the cosine of 2x minus pi over 4. And put that all over v squared, which is x to the 4th. You can simplify more if you want to, but you don't have to, especially if you're plugging in a value for x to find a gradient. Three minus 2 cosine of 5x to the 4th. Okay. What's the derivative of the inside? Negative 2 times 5 times negative sine of 5x, since cosine becomes negative sine. So the two negatives will cancel each other out, and we get 10 sine of 5x for the derivative of the inside. We multiply that by the exponent, keep everything in the parentheses the same, and subtract 1 from your exponent. So we can simplify just by distributing this 4. And the derivative is 40 sine 5x times 3 minus 2 cosine 5x to the power of 3. Okay, and finally, let's talk about if we have an exponent in our function. Sine cubed x. So this is the same thing as sine x to the 3rd power. Remember, they just write it this way because it looks nicer. So we're going to find the derivative of the inside, which would be cosine x. Multiply that by the exponent, then multiply that by what's in the parentheses and subtract 1 from the exponent. So 3 cosine x, and then sine x squared is the same thing as sine squared x. So this is your derivative. Please put problems you have to go over in the homework on the Google Doc. If you need the link again, let me know. I noticed now that some of you are waiting to the last minute to start your homework. Remember that we need to show them enough evidence from this quarter to put into your folders. So I've tried to slow down a bit, but we still have to keep going because if they want to check your work, I need it to show everything from the entire paper too. Okay? So please start your work when you're supposed to. Get help from me when you need it. You shouldn't be sitting there struggling for hours. So I can't help you if you don't let me know that you need help. Okay? Hope you're all doing well, and see you next time.